Good morning, everyone. My name is Pradeep. Along with me, my colleague Srinivas. We are from NetApp. We work out of the NetApp Bangalore office in India. We would like to talk about today our journey to smartness with respect to the data protection. Now, when we talk about data protection, we will be talking data protection in the perspective of NetApp operating system, that is data OnTap. So we are going to discuss here about our journey so far, what we are seeing in terms of our uh, simplicity and what are the new opportunities we have. And based on that, we would like to take the discussion forward. Next, please. So here, me, Pradeep, and my colleague Srinivas are presenting. However, we are actually a team of 4 people, consist of, along with us, Kanappan and Vinayak. So whatever we are going to present over here, that is essentially a collaboration of 4 people. Uh, Now let's look into what all we are going to discuss today. So today's topic or our discussion will be pretty interesting. Before diving into the details of our story, we would like to give you the perspective of the solution space. We would like to talk about NetApp OnTap System Manager, or what is the OnTap System Manager is. So we are from the System Manager team. We would like to give an overview of that. Followed by, we will be talking about data protection, mostly concerning around the storage layer. We would not talk about the end-to-end application-centric data protection. We will be talking mostly in the storage data protection. Following that, we will be specifying the problem statement that we are going to solve. After that, we will look into how we are going to solve it. What is our approach? We will be talking about what work we are doing over here and what are the potential future directions where we can potentially have a chance of collaboration. We would of course touch base upon the value proposition, and ultimately we will conclude with the next steps. Next slide. So, of course, we are giving here the presentation, but our sincere thanks to our user experience team out of here in Bangalore NetApp, because they are the people who actually told us initially this phenomenon which we call the death by Snapmare. So Snapmare is the terminology that is used for NetApp data on tap data protection world. So we are really thankful for them to give us the insight about the problem, which actually make us excited to work on that. Ultimately, which leads us to present in this esteemed forum. Next, please. Now let's delve a little bit into OnTap System Manager. I think data OnTap is nothing new to the audience over here. This is the NetApp operating system for managing the NetApp storage array. And we are the system manager, which is essentially the face of OnTap. We are the front end tool by which you can manage OnTap, just pointing the browser to an OnTap installation by pointing to the cluster management IP. So what we do actually as a part of system manager, what we do is essentially manage OnTap. So by OnTap management, what we trying to say is that we are actually doing various CRUD operation to manage the various OnTap objects. So OnTap is consist of various objects, right? Storage, networking, protection, protocol. We actually provide the create, read, update, delete operation to these OnTap objects in a very simplified and very intuitive manner, such that many of the complexity is hidden from the end user, and we are presenting a nice intuitive interface for the end user. Along with that, we do provide various kind of dashboard, like for example, health, capacity, performance, and we provide various value-added visualizations. For example, a end-to-end storage to host mapping, hardware visualization, etc. Of course, we will delve details into that, and we will go to go to a nice small video demo of showing what is the total overview. Yeah. So okay. So let's look into a system manager demo. So system manager, whenever you log in, you will get a nice dashboard in which you can search different objects on the top. Not only objects, you can find out different kind of operations that you can perform. We have the dashboard, that is our main landing point, where we show health, capacity, and performance information, along with a basic idea about host to storage mapping. This performance consists of historical as well as live. Now let's go under storage. In storage, you can see we have many objects. Out of that, let's come one of the main objects called volume. So in the volume, we show many information which is important for end user. We can allow user to create a volume which the minimal input, or for advanced user can potentially go to a advanced screen where user can manage various bells and whistles. Beyond the volume, let's go to the networking. This is one interesting area where we show various logical interfaces into one place along with other kind of network entity. We have the events and jobs on which user can potentially see different EMS events coming out of system along with their details. Let's come to the protection, which is we are going to discuss today. We have a protection dashboard where we show which all volumes need to be protected, along with if there is any data protection related issue. We have the host, that is SAN initiator groups, which are basically IQN or FQDN for SAN host, an inventory of that, and of course a management of that. And we of course have the cluster, where we show various kind of settings, like for example, NetApp auto support that is sent back to home. We have SAML authentication, LDAP, user and role, SNMP, this kind of various settings. If you are in a old time system manager user, you can always click on the switch to the new experience and you can see the revamped system manager. Okay, so you have seen the system manager demo. We would like to share with you our journey so far on improving the system manager as the face of OnTap. The primary point that we have is the operational simplicity, because we believe the operational simplicity comes from two main fundamental aspects. One is, of course, providing fewer knobs to the user such that user needs to spend lesser time on managing the storage arrays. And on the another on the another context, we would like to increase the smartness, or in other words, introduce the smartness such that we as a software can able to take more decision by the software itself, instead of depending too much on the user, that is mostly given towards focusing on the tasks than managing each and every individual object. This is, primarily that these two fulcrums are governing the fact that the user persona that we are targeting or pertaining to us is the IT generalist, because we know in the data center now we have a convergence of various roles. Earlier it used to be application admin, network admin, storage admin. Now there is a single person who is IT generalist, who is managing the whole stack, up to from the storage up to the application, maybe up to the container management, right? So to ease the IT generalist life, we so far embrace the journey of simplicity. We would like to go forward with introducing smartness, and that is going to be the main pivotal discussion point we have in this talk. Next. So what we have learned on the way. The new interface of system manager that we are providing, customer actually started using it and they are really liking this new interface. However, we still believe that we have opportunities to improve. The opportunity is essentially to reduce further the operational complexity. In today's talk, in this esteemed forum, we would like to talk about one such opportunity of how we are using data protection as one of the option where we can use many of the analytical ability, and we can able to proceed from there to make things more easier, more user friendly from end user, such that it would be number one, task centric, number two, reduce the operational complexity. With this, I would like to hand over to my colleague Srinivas to take the talk from here onwards. Srinivas, over to you.
Hi. Yeah. Hi. Thanks for setting that context very beautifully, Pradeep. We are in the purview of System Manager, which is a graphical user interface to manage OnTap. And I'm going to talk about this unique opportunity that we saw to introduce some smartness into the application. So I'm going to talk about smart defaulting. So what is smart defaulting in the context of a graphical user interface? Uh, Smart defaulting is when an admin comes to a workflow and has to make a decision, maybe has to pick a choice from a drop down, and then he sees that the choice that he wants to select is already selected by the system. That is the smartness the system shows, and the value that the user wants to be selected is defaulted. So this is what we call smart defaulting. It is basically to take the decision making power from the user into the application and probably try to make the decision on behalf of the user, thereby empowering someone like a generalist to do some more advanced operations. So when we come to make decisions on behalf of someone else, it's not going to be a one size fits all kind of a solution. We need to have some smartness built into our application too. The area where we are going to focus on smart defaulting is data protection. Let me tell you briefly about how the OnTap data protection works. You have a primary cluster where you have some volumes and some user data in that. You have a secondary cluster where you would like to backup or mirror. Mirror is a more like a incremental process, and backup is a vaulting solution. So you primarily try to save the user data, backup the user data into a secondary cluster, and to do that, you have something called a snapshotting technology. So you take local snapshots of the incremental data that gets into the primary cluster, and you basically tell the system through a policy on what snapshots to transfer and in what frequency to transfer and to which secondary storage. This is called the type of policy because that's basically tell the system whether you're going to do mirroring or you're going to do a voting. Then you select the uh, primary and secondary storage which are involved in this relationship. Then you select the policy. The policy is the one that is going to tell what are the snapshots that needs to be transferred to the secondary and how many of them to retain. And the fourth aspect of that is scheduling, when to transfer those snapshots to the secondary. We also have complete operational management support for data protection through System Manager. You can roughly relate it to as the DR lifecycle management, where we give some advanced operations to users too, where they can do activation of the destination, reactivation of the source, breaking or making these relationships, and such advanced operations are also possible. So through our graphical user interface, we have tried to strike a very fine balance between operational simplicity and also advanced user preferences. Coming to the opportunity that we actually saw and we are trying to solve, which we'll cover in the talk, is when you're trying to set up this kind of a relationship, and when you're in a modest to large environment where you have a bunch of clusters and there are thousands of volumes that you're protecting, there are two decisions that the storage admin has to make every time he's setting up a relationship. One is to find the best fit policy, and the second one is to find the optimal schedule to transfer these snapshots. So the policies are governed based on different reasons. I'll first show you how a policy looks like. So a policy has a name, and then it basically tells what are the labels that will be associated to the snapshots and which needs to be transferred, and how many such snapshots needs to be retained in the destination. So that will be given by the retention count. So the retention count here becomes our major point of concern. Uh, Let me go back to say what happens when we have hundreds of such policies which are created, which as the system scales, the policies are also scaling organically. And there comes a point when the storage admin is struggling to make a decision on which policy to choose today, because the storage admins also keep changing over the period of time, but then the policies keep growing. The second problem is when to make these transfers happen. There are this can be a clear cut problem. You could actually see that this is a standard problem whenever it comes to scheduling. You would always like to schedule your jobs at non-working hours and at times when the system will be able to transfer it much faster. But there are also some other concerns, like some users are going to be at a virtual machine scope. So we have something called a vServer or a storage virtual machine concept, which is a virtual concept above the regular thing, where only a part of the storage system is abstracted and exposed to one particular user. Whereas there are cluster admins too who can get a complete view of the whole cluster. So in such situations, there can be some hindsight on the storage admin on when to schedule the transfers for a particular volumes relationship. Let me now talk about how we can help the user to achieve this without his intervention or without much thought. So let me first talk about the policy optimization aspect. So like I told you, we have a data protection policy, which is going to talk about what are the snapshots or replicas to transfer and how many of them to retain. The how many of them to retain becomes a primary variable on these particular policies. So we see that when we spoke with our internal IT teams who also use NetApp systems, we initially designed the system to probably have 3 to 4 policies which are inbuilt in the system. But then, as the system scales, as the customer uses, they are creating policies of their own, and there are hundreds of policies in a modest to large environment, and uh, the variable is the retention count, and which is very meager. We saw that there are policies which are very short term, there are policies which are medium term, there are policies which have a retention period of a very long term. So we thought we could essentially split this and optimize them to have just 3 to 5 policies, and that should be enough for a storage admin to manage these relationships very effectively. So what we did is we saw a clear clustering problem here from the policies that we saw in our customer environments. And we thought we will propose clustering them using some very simple unsupervised machine learning algorithms like k-means clustering. And this worked very beautifully for us because we do our processing on the browser, and we wanted something with a linear complexity and which is super fast. And k-means just fit our bill very nicely for this purpose. So when we tried, we got very good results to optimize our policy sets. So what we did is optimize these hundreds of policies into 3 to 5 policies. We could then use a simple decision tree and pick up the policy which is most likely to fit this particular relationship that the storage admin is going to create, and default that in that workflow so that that decision is already made when the storage admin visits that workflow. And we also need to do some more things like applying these policies to existing relationships, because we are going to remove the policies that were already created with these optimized policies. So such activities also need to be taken care by the application in the background. I have a video demo lined up, so I will show you how we try to realize this solution. But let me talk about our approach for the second problem that I spoke about, which is about scheduling. So the schedules in OnTabs are regular Unix cron jobs. And if you see, these can be like transfer a snapshot every 5 minutes, transfer a snapshot every hour, transfer it on a daily basis, or transfer it on a weekly, monthly, or whatever the user feels like. So the user is not limited. User can create their own custom schedules on when to transfer. This was basically a flexibility given to the user, I think, in the beginning, so that the user can schedule these jobs in a non-overlapping manner for effective transfers. What is death by Snapmare? Pradeep touched upon this earlier. So this, when we heard about this, we were really intrigued, and we thought we should give an attempt to solve this problem. So to give you a very relatable Bangalore analogy, this is like your office is in South Bangalore, and you're probably trying to reach there in a peak time, but you need to hit the Silkboard Junction. You see that when you're traveling in the peak time, you're getting stuck there because there's too much traffic, and then you think maybe if I prepone my travel time by half an hour, I should probably be good. And then you try to start half an hour early the next day, but you still end up in Silkboard traffic. So, but then that's about Silkboard traffic. But then the scheduling in OnTap probably works better. So you could actually find a window where the snapshot transfers are going to be more effective. So this can be a little difficult if you do not have the appropriate visualization to support your decision making. So we have tried to combine these two and give a solution here. So the smart defaulting of Snapmare schedules is again when you hit the workflow to create a relationship, and when you have to select a schedule. This if the system tries to find an optimal schedule on when to do these transfers, then that will be the best thing that we could give the storage admin. So we have created a drill down schedule visualizer, which will give a very nice outlook kind of a view on when you could actually, what is a window which will be the lean period. But this lean period needs to be known for the future. You could also look at it historically and try to make a decision retrospectively. But then what we thought is let us try to predict how the next 24-hour timeline is going to be for this system when it comes to Snapmare transfers. So we try to build a visualizer for that too. And we also built a predictor using some parameters. And this we felt will help the storage admin to pick up that free window in which the transfers will be faster, and the system can try to avoid getting into a death by Snapmare kind of scenarios. So let me go to a demo that we have for you. So we try to build this prototype on Classic System Manager. And this is our volumes relationships page where we give an inventory of what are all the relationships that are going out from this cluster and what are all the volumes and storage VMs associated to it. So let me go ahead and click on the create. So this is where we try to create and or set up a Snapmare relationship. And initially you will have to select a storage virtual machine. So this is the virtual server on which volumes are going to reside. The first decision you have to make is you need to know what kind of a relationship that you're going to create, mirror or mirror and void. And then you try to select the source volume. The destination is the current SPM scope in which you are working on. And then the final two decisions that we have to make is the policy optimization or the policy selection. So if you look at the current way in which the user is going to select the policies, no matter how how much simple you make this widget, no matter how much information you try to throw to the user on this particular widget, you eventually need to pick a policy by scrolling through a grid or by looking into a dropdown or by searching and selecting one. And at that point, you do not really have a lot of information, and it can become tedious when there are hundreds of policies. So let's see how it works right now. This was the kind of widget that we had in System Manager up to System Manager 9.6. And the user just goes ahead and picks a policy that he seems fit for this particular relationship. But what we try to do to optimize this so that we have a lesser bunch to deal with is the policy optimizer. So this is the new button that you see on this workflow that we have introduced in this prototype. And on launching this workflow, what happens is pretty interesting. So we trigger the k-means algorithm with a default clustering number of 3. And what happens here is we have about 50 relationships in this cluster, which are governed by about 20 policies, and which are all for the mirror and wall type of relationships. What the system has done is run the k-means algorithm to try and cluster all these policies into 3 buckets as specified by us. And it gives an account of what are all the relationships and what are all the labels that are going to get affected by this, and what is going to be the new centroid, as in this is going to be the mean and for these clusters, and that will be our new retention counts. the user can still go ahead and play with the number of clustering that he wants to do. So you could practically increment it to 5 or 8, depending on the type you need, so that you get to see the amount of policies that you will eventually get. And you could settle at wherever you feel comfortable. So we have this built for different policy types. So I'm just scrolling ahead. And we also have some facility for the user to exclude some of these policies if he feels it's an exception. There are certain outliers which are going to be there, which needs to be treated, but the algorithm might not know that upfront. So we have given explicit control to the user so that they could go ahead and exclude the policies which the algorithm has incorrectly bucketed, or if they want to exclude. So we have this for mirror type, vault type, and mirror and vault type. So for this particular relationship, we are trying to build a mirror and vault. So I'll say I'm fine with this kind of optimization and I would apply. When I click on apply, the optimizing policy step is actually going to go ahead, create these new policies, delete the old ones, and associate the appropriate policies to the ones that it is replacing in the existing relationships. So once we do that, we can see that the whole policy management is going to be very simple. We see that we just have like 3 to 5 policies that we have, the other two being the default system created policies. We are not touching that. And our policy optimization is simplified. So for the subsequent entries into this workflow, the user will, once the user picks an SVM and a volume, we could actually see that we can build a simple decision tree model to say that this particular SVM usually has some kind of data which needs to be retained for only this much amount of time, and we could default that policy automatically. Now, coming to the second problem of scheduling. So this is a very major decision because any mistakes in this is going to impact the system, and we see that some of the storage admins keep visiting these workflows on a daily basis to try and find that optimized schedule. So when you click on the schedule visualizer, we try to give a weekly view of what are all the protection jobs that are lined up in the system on a particular day of the week, and how much the bars essentially represent the number of transfers that are going to happen on that day. But this is clearly not enough. So we have a drill down view where you could drill down into an hourly view of the system, where you could see at each hour what are all the transfers that are scheduled. So based on this look, you could still rearrange your transfers so that this happens fine and it is overlaid. You could see your working hours and non-working hours and when your transfers are scheduled and so on. But this information is again not enough because transfers have a lot of other factors which will affect them. So there are these snapshots are going to be queued within the system at a particular time, and then the system is going to put these on a backseat if there is a more higher priority process, and then these needs to be transferred over the network. So there is a network latency, and then there is the receiver who is going to also affect the transfer rates. So what we have seen is we need to give a much detailed third level view, which is a schedule visualizer, which is going to talk about the duration of transfers also. And in this view, we have a predicted result of the next 24 hours of the timeline of a day on how these transfers are going to go ahead and how these are going to look like. So we could retrospectively look into our past transfers and try to predict what the next 24 hours is going to look like. So here you see the Gantt chart. This is a Gantt chart representation where each of these capsules represent the duration of these transfers. We saw that all these 14 transfers were scheduled to start at 12 a.m., but then they haven't really started at 12 a.m. because of certain lag in the system. Some of them have started a little later, and the transfer durations have also taken so much time that it has overlapped into the next hour. So if you actually feel that 1 o'clock is probably the next best time to schedule your transfer for this relationship, maybe it is not, because we can see that some of these are spilling over to 1 hour 20 minutes or 1 hour 12 minutes. So we should probably pick the number 2. So this kind of a visualization and prediction will actually help the user to pick the right slot and probably do this in one shot and not redo this over and over again. So we have picked the 2 o'clock schedule. We'll try to go apply it. And once we have applied, our relationship can be created. We could also smart default this whole thing by, for the subsequent visits in the workflow, you could automatically set it. And let me tell you how we went ahead with calculating this prediction and how we could smart default this. So we could build this based on a simple heuristic. So you could just estimate an average data transfer duration for each of these transfers based on the snap difference. So the snap diff is nothing but the difference in data that needs to be transferred at every subsequent transfer. You could just look at the data transfer rate based on your throughput of the system and arrive at a very simple transfer duration. While this works, but it does not work very well. If you apply linear regression, I'm not able to share much more details about this at this time, but let me quickly get to the results on what factors we saw were affecting when we try to do a linear regression. You see that the size of the snapshot data and the network latency is obvious factors, but the lag time that was there introduced because of queuing of these snapshots in the source cluster itself could be a factor. And the CPU headroom in the source and destination were also important factors that were affecting the transfer rates. So this was how we tried to introduce some smartness into this workflow and try to help the user to make these two decisions. So we have these data production optimized setups which are purely created for data production, which have thousands of relationships flowing into one particular cluster, which is going to be destination placed in different geographies. So in such scenarios, we actually see that such solutions are going to work out really well to ease the life of the storage admins. And these large deployments are also struggling without a scheduled calendar and visualizer. So that is adding a lot of value. And this was very well appreciated when we spoke to our internal IT teams who are advanced storage admins. And there were also some proposals that were coming up to move from this Unix cron type scheduling to window-based scheduling, where also our solution fits in very well. But we know there is miles to go. The application modernization is a recurring process. It's a very long journey, and we are still undergoing that journey as we speak. But one thing that we realized is we should probably think about long-term management of these management workflows itself. So when we initially design, we always think about CRUD operations when we come to management workflows. It's CRUD is a create, read, update, and delete operation that we typically give for an object. But we should probably start thinking about mCRUD, managing these CRUD workflows itself, because the policy optimizer or the schedule visualizer buttons that you saw in those workflows need not be introduced when the system is afresh. It needs to be introduced after the system hits a certain scale. And that is when the user will see a real value of using those. So this is about managing that workflow itself. And this requires some smartness and some different kind of thinking. Uh, and predominantly enterprise applications are policy driven and schedule driven. So in these scenarios, I think it really makes a lot of sense for us to look into such unsupervised learning, which are very simple to use and which can be very effective when used too. So for closing, I'll probably hand it over to Pradeep. Pradeep, please share your closing thoughts on.
Sure. Thank you very much, Srinivas. Your talk was very insightful. I have learned quite a few things from you, and I hope sincerely our audience also.
I hope
So it's
to.
a journey, right? We have started with the simplicity, keeping in mind to make our end user who are predominantly IT generalists to make their life simple, to make it more task centric, and we take it one step ahead to embrace some of the analytics, as Srinivas was showing in some of the previous slides, into it, such that we can build from a cart management tool to an MCART management tool. Now, in this journey, we will, of course, we want to say that we have just started the journey. Of course, it's not the end. We have picked up the data protection as one of the vertical on which we should start the journey, but the same idea can potentially be extended into many other aspects of management of storage array. And we believe, or rather, we would like to hear from you or what you people think about it, and what are the areas that you think we can potentially collaborate to get a better understanding of this system. And hopefully, in this particular talk in the STC Bangalore 2020, we are talking about the management aspect of Snapmare of data protection. Maybe in some upcoming talk somewhere, down the line in some other years, we may get more and more such use cases where by using MCUT, we can able to solve it even better way. We would of course like to discuss that also with all of you, your people, to give your feedback and to keep you people updated on the way we are thinking. With this, from me and Srinivas, NetApp Bangalore, we would like to thank you everyone for joining this session and to listen to us. Thank you very much. Have a great day to all of you.
Thank you.